Brad Buckham and Mark Warren to come up. We're missing someone. Or is that David coming through behind? Yes. Okay. David, welcome.
Thank you. Sorry about that.
No, not a...
bit of a family emergency. It's okay, though.
You're all right?
Yeah.
Okay, so I will cede the podium to you, and
Thank you very much. Yes.
looking forward to the
Thank you.
panel.
Well, it's last session, so hopefully it'll be a good one, a nice note to end on. It's been a very exciting day listening to all the talks. So we have a very esteemed panel here. Of course, we heard Senator Galvez talk this morning and really set the scene, actually, in many ways for the discussion that we're going to have in this last panel. And I think, a very nice introduction to you as well. I don't think you've met the other two panelists here. So we have Mark here, who is with Fortis, and he is the director, I believe, in this case, of business innovation, correct? And involved in doing data analytics around a number of areas related to energy. So it'll be very interesting to hear his talk. And then we have also Brad Buckham from the University of Victoria, who's focusing on marine research and is a chair of the Department of Mechanical Engineering and a member of the Institute for Integrated Energy Systems, which has done a lot of work in the space of clean energy. So perhaps what I would ask, our plan is to have about, roughly a 12, 13-minute presentation. All the panelists will do that, and then following that, we'll have some questions and then open that up to the audience. But as in the previous panels, I might ask each of you, if you want to say something about yourself, please feel free to do that to set the context for the discussion. My name is David Wilkinson. I worked in industry for high tech for about 20 years in areas related to fuel cells and advanced lithium batteries and some other areas that are related to clean energy space. And I've been at the University of British Columbia since 2004 in the Department of Chemical and Biological Engineering. So what I thought I would do is give you a little bit of an overview. In fact, some of these points have already been touched on by the Senator, but maybe there's a few that haven't. Again, just to remind you and provide some areas or points for discussion as we move forward with the panel. So I would like to start, first of all, these are kind of the areas we'll be talking about. But we talked a little bit about growth. Our world is based on growth. Is that something that we can change? It's very unlikely because it's been like that for a long period of time. We are seeing a significant increase in energy demand as our population grows. As it was mentioned, we're over 8 billion people now and rising what that scenario looks like in the future out to 2050 or 2100. We have to wait and see that, but there's definitely scenario analysis. So a very significant increase in population means an increase in the growth of energy. We all have to do our part, no matter how large or small we are as a country. And this was, I think, made very clear from Kyoto, which in many ways was a failure because it just singled out some of the developed countries. And I think the reasoning beyond that has been that every country has to participate in solving this problem. So we ask about the sustainability of fossil fuels. The interesting point here is that sustainability and the whole concept of fossil fuels, how long they would last, really 10 or so years ago was largely based on the supply that we felt we had remaining, which means that projecting out to 2050, there was not as much emphasis on starting to move to other sources like renewable energy. However, once climate change became embedded in people's thinking, that's become by far the primary driver now, not the sustainability of fossil fuels, although that still is an overlay as well. So we know there's been a lot of analysis done by the IPCC, the Intergovernmental Panel for Climate Control. Some of those scenarios look at more of a mitigation process where we're trying to get to net zero 2050. However, if other scenarios such as business as usual or even a greater use is going to lead to much higher temperatures, that's going to require an adaptation process. We heard a lot about that this morning. That means, for example, flooding, higher temperatures. So there really are two very distinct approaches. And it appears that at this point, we're still on the business as usual projection or trajectory. In 2021, there were two, excuse me, very important documents that came out. One from the IPCC, doing the scenario analysis. It was a physical assessment of where things are. And then the net zero plan by the IEA, International Energy Agency, which laid out really a map, global map for energy to move to net zero 2050. And these are very good to read. They give quite a good insight on a global level. Obviously, that changes depending if you're looking at a regional level versus a global level. But overall, I think there's a lot of very good information in that. So one of the aspects of that is looking, at the 2030 scenario, which is the transition, if you like, and then the 2050 deadline. Embedded in this is the growth that's related to population growth, but then a number of measures to decrease, excuse me, the emissions. And you can see a breakdown there of the different areas and the role that they play. Certainly demand and plays a very important role. Also, other areas like the renewables, of course, a large area, and even carbon capture, utilization, and storage. So this has been laid out. It's really difficult, again, raising the question of whether we can deal with the growth in demand that is occurring. If there's any opportunity there, that would have a very big impact. We come to carbon capture, utilization, and storage. This is an area that's being adopted and focused on a lot in Canada, maybe not so much in other jurisdictions, but there are potentially a lot of considerations here. And one is, if we're starting with fossil fuels upstream, and we could include biofuels, I guess, with that, We have to be concerned about fugitive gas leakage. We know that the global warming potential, for example, of methane is like 86 times that of CO2. One molecule of methane is equal to 86 carbon dioxide molecules. So it can have a big impact if we don't control that significantly. And then the capture we have, and then what we actually do downstream with the captured CO2. A lot of our policy around, let's say, the oil sands, for example, involves really only looking at upstream emissions and not the downstream emissions once that oil is distributed and used. So we have to be very careful about how we think about this because we don't want to create a net issue in terms of using carbon capture. And if we look at the total energy supply for the net zero energy plan, what we can see here is there's a very significant decrease in fossil fuel use by 2050. If you look at roughly where we are today, it's a very significant decrease, and a lot of that room is taken up by renewables in particular. And so this is a very different type of composition than what we have seen in the past when we've been looking at just the sustainability of fossil fuels and how we were going to adapt to that. And the other point that the white dashed line shows is that essentially COVID, the pandemic, is really the only thing that's moved this curve in terms of energy that's used and CO2 emissions. So of all the COPE meetings that we've had so far, I believe around 27, we really haven't moved any of these global curves at all. But COVID is really an example of where we are able at least to budget a little bit. In terms of the growth of renewables, certainly we're seeing that solar and wind are globally the largest contributors to renewable energy and have a very fast growth rate. But even so, that's only contributing in the range of 6 to 7% right now of total energy that's required. So it's still on the low side, but the growth is very significant. And certain countries like Germany, for example, renewables take up a large part of their energy portfolio, accounting for almost 50%. So some countries are moving forward very quickly with renewables. China's another great example, even though it has, it's balancing that with coal use and coal power production to make the transition happen. There was some mention about economics that was discussed, particularly with respect to the nuclear industry. What you can see is that if we look at the costing of energy from renewables, it's come down significantly to the point today where solar and wind is actually less than fossil fuels, depending on the scale that it's being done at. And we can also see for conventional nuclear that the cost has gone up a little bit because of all the additional costs of regulation and everything else. So essentially, the economic arguments for not going to renewables are not there anymore. There's an advantage. What we need to talk about is storage, because today we throw away most of our excess energy, or it's curtailed, and this is an enormous opportunity for us to implement that excess energy to produce things like hydrogen, for example. Otherwise, it just gets thrown away. You can see there in the hatched area, but we're talking here about a significant energy, for example, in Canada or Ontario, in the terawatt-hour range of energy. So this is a really enormous opportunity for us as we move forward. The problem is that for electricity, and it's part of the 2050 plan, we're moving very, very fast to electrification of everything. We don't really have the reservoir capability for electricity that we do, for example, that we've established with fossil fuels. And so we don't have reservoir capability. Batteries will provide us with a certain level of that storage, but not at the reservoir capability where we're talking about weeks or we're talking about months. So we really need to look at other forms. Pumped hydro is limited because of the geological locations that we have available. Hydrogen, again, is a very good option here if it's done at large scale. And I'll mention here the coupling of hydrogen with the electrical or electrification economy makes a lot of sense. There's a lot of applications that we can clean up by using hydrogen, green hydrogen, for example, or hydrogen with very low emissions in a number of different industries that it cannot be done any other way. You know, if we look at things like, for example, ammonia production for agriculture, or we look at, you know, the petrochemical industry or other chemical synthesis, agriculture. There's many different areas, including transportation. Excuse me. And the benefit here is that hydrogen is a chemical, but it also can be transferred into electrons very easily. So that's a very facile reaction that allows us to couple electrons, essentially, and chemicals, or E-fields. When we talk about infrastructure system, we're at a stage now where we're starting to commit to different infrastructures. But again, I think we have to be very cautionary about that commitment because the longer term breakdown could be quite different than the shorter term. And this is a very interesting analysis that was done by the Forschungszentrum in Germany for the German government, which actually showed initially that EVs based on batteries, you know, it was cheaper to set the infrastructure up for that, but at a larger volume, it actually became more expensive. So, you know, depending on what scale we're looking at, it will have a lot to determine what that endpoint looks like. So committing too early just to one path can potentially be dangerous. And I'm almost finished here. I just want to mention the impact in the choices that we make about the technology that we're going to use. I work in the lithium battery industry. I also work in the fuel cell and electrolysis area. And certainly when we're looking at the critical minerals that are required for different technologies, they are very different. So we need to take that into consideration. Also other things like water usage as well, and impact on biodiversity. And I use lithium as a good example because it could create a lot of the same issues that we have with oil and gas that we've encountered over the last 100 years because supply chains are controlled to a large extent by certain countries and the availability of it and what it actually does from an environmental point of view as well. And you know, we have a very large mining industry in Canada that works abroad. Right here in BC, a lot of companies have their headquarters here. We have companies here that are considering doing ocean mining, for example, in South Pacific Islands. So potentially this is an environmental disaster because of lack of oversight or even proper regulations around doing that. So this is something we need to be very, very cognizant of. And then I'll end on this slide here because I think it's a really nice segue to Senator Galvez to give her talk here. But I think we need to really think about the triple bottom line, which is balancing the social, economic aspects, but also technology and policy, but all of that done in an eco-centered type of approach as opposed to an anthropogenic or a human sort of based approach. So our decisions about the paths that we take need to take into consideration water use. They need to take into consideration the impact on biodiversity. They need to take into consideration the availability of the materials that we're going to need to be able to do that. So I think on that note, I will end, and I would ask Senator Galvez to give her talk. Thank you.
Yes, thank you. So this is supposed to be short. We can start with the second one, which I already presented to you. Next one. Oh, no, it's me. Sorry. Yeah. So I presented this earlier, but I want to start by saying that as most of you are academics, you have classes and you have given your courses. So when I landed in the Laval University, I was hired to teach a mandatory course that has become mandatory because Engineers Canada made it mandatory to all engineers, which was environmental impact assessment. I don't remember it. I don't know if you know. That happened around 95. It became mandatory, and it was 3 credits, and you had to have every engineering. And so my class was 300 students. And one thing that I can say about the education in Canada that is so good, I've earned my Ph.D. at McGill, and when you end up finishing in a very prestigious university, you don't need to find a job, the job comes and look for you. So when I finished my Ph.D., I had 3 job possibilities. I could have been working to SNC Lavalin and maybe involved in the corruption scandal that it's today in the news because it's a drama. I could have gone to work to the World Bank Center because they were now giving loans to developing countries based on environmental impact assessment. So I was going to open that door, but then I wouldn't be talking to you because that building exploded on 9/11. So the third option was going to Laval in beautiful Quebec City and raise my 2 daughters. But I had to cope with giving a course to 300 students. So I remember this is exactly 32 years ago. And my class at that time already was talking about energy transition. I was already at that time comparing solar, wind, biomass, nuclear, hydroelectricity, coal,